Hi class, we're looking at lesson 4.5, which is compound inequalities. Compound inequalities are inequalities that are joined by either the words and or. Let's look at two compound inequalities here and compare the two. The first one, we're looking at all real numbers that are at least -1 and at most 3. So we have b, which is our variable, is going to be greater than or equal to -1, and it's going to be less than or equal to 3. We're going to graph both inequalities on one number line, okay? They're graphed on one number line, and we're going to show that all real numbers that are at least -1 and at most 3 are going to fall between -1 and 3. So a number that would fit both pieces or both inequalities would be 0. 0 is greater than -1 and it is also less than 3. Numbers that would not be a solution to this compound inequality here would be 5, because while it is greater than or equal to -1, it is not less than 3. Let's look at another example of a compound inequality. Again, these are just two inequalities that are graphed on the same number line, and they're joined by either an and or an or. This is another and situation here. We want to look at all real numbers that are less than 31 but greater than 25. So we look at numbers that are less than 31, so 31 is greater than n, and n is our number here. So that would be the graph 31, open circle because it's not equal to, going to the left to be less than. Now we don't continue that the whole way because we're looking for the overlap. That's what that and tells us. We want numbers that fit both pieces of this situation here. So then the second part of this situation is n is greater than 25. So here's our 25, and again, open circle here because it's greater than. It's not greater than or equal to. So open circle, and in this case, greater than is going to our right. The overlap where they meet is the and situation, and these numbers would fit both criteria. So like the number 28 is less than 31 and greater than 25. Now notice how compound inequalities with the and, they're usually written as two inequalities and they have the word and separating them. However, if you look here at this first example and then also our second example, you can have your variable in the middle and combine both inequalities into one large compound inequality here. This is understood to be an and situation. On the next page, we'll show you an or situation. You may pause this and want to replay this section. If not, move on to the next example. Our second example is, I apologize, this is a second example of an and situation. We're solving compound inequalities. We have 5 is greater than 5 minus f, which is greater than 2. Okay? So we are going to solve the compound inequality. If you want to think about it, ignore the first half of this problem. Or ignore the second half of this problem. Ignore the greater than 2. So you've got 5 is greater than 5 minus f. So how would you solve that? Well, first we would subtract 5 from both sides, and we'd be left with 0 over here. Don't forget, 0 is an answer. And we're left with 0 is greater than negative f. Well, we want to find out what f equals, so we then have to divide by a -1. Remember what happens when we divide by a negative? We have to flip our inequality symbol. So we flip our inequality symbol, and then we get f is greater than 0. We then look at the second half of the inequality here. Okay, and again, we can ignore now the first half. we have 5 minus f is greater than 2. Again, you've solved these 1 and 2 step inequalities and nothing has really changed. All right, we have 5 minus f is greater than 2. So again, we're going to subtract 5 from both sides, and we're left with negative f is greater than negative 3. We again have to divide both sides by a negative. Remember what happens when we divide by a negative? We have to flip the inequality, and then we get f is less than 3. So we have this compound inequality that's left here. And if you want to think about it, it is basically two inequalities joined by the word and. F is 0 is less than f, and f is less than 3. So what numbers would fit? Well, think about it. If we have an open circle on the 0 in our number line, there's my poorly drawn number line, okay? Here is 0, and let's say here is 3, and again we have an open circle on the 3. F is less than 3 is going to go this way. F is greater than 0 is going to go this way. So between 0 and 3 is our solution. So you've got 1 and 2 in there, and of course all of the decimals that fall between them as well. So one number we could put in here would be 1. Let's go back and check our problem. Our original problem is, let's move my happy face that we were ignoring the first half. So our original problem is 5 is less than 5 minus, and we said we were going to use 1 here, which is greater than 2. Well, 5 minus 1 is 4. Is 5 greater than 4, and is 4 greater than 2? Yes, it is. So there's a quick check. And we can see our graph here as well. Because it's written this way, it's always understood to be an and. Okay, I'm hoping example 3 has an or. You're going to turn me into a liar here. Ah, yes, here we have an or situation. Okay, so we're writing an inequality that represents the situation. All real numbers that are less than 0 or greater than 3. So if you think about the first half here, a number that is less than 0, so that's going to be n is less than 0, or n is greater than 3. So here we have n is greater than 3. This is an or situation here because, first of all, the problem tells us an or situation. So what does that mean? Well, we are looking for a number that fits both we don't have any numbers that fit both situations. So one or the other is going to have to work. Let's pretend these are students from Mrs. Mona's homeroom, and these are students from Mrs. Brennan's homeroom, and I need to pick one or the other. Okay, so I could pick a student from my homeroom or a student from Mrs. Brennan's homeroom. What's in the middle here? Well, these are the students from Mrs. Owen's homeroom, and they aren't fitting our criteria for whatever reason. So just one example of an or situation. Here's a fourth example of an or situation. Okay, and this is a compound inequality. Let's look. So you actually have, with the or situations, they always write them out as two separate ones because they are completely different and it's very hard to relate them. So we've got 3x plus 2 is less than negative 7, or negative 4x plus 5 is less than 1. And we're going to graph our solutions here. So what I want you to do is I want you just to look at each inequality. I want you to look at this first inequality here. 3x plus 2 is less than negative 7. So we're going to solve that inequality by subtracting 2 from both sides and then dividing by 3, and you're going to get x is less than something. And then we're going to solve this inequality by subtracting 5 and then dividing by negative 4. And again, we're dividing by a negative. That bell should be ringing. Let's look at some of the work here. So here we subtract 2 from both sides and we're left with 3x is less than negative 9. We then divide both sides by 3 and we're left with x is less than negative 3. They're joined by this word or here. Very important. we have the second inequality, negative 4x plus 5 is less than 1. We're going to subtract 5 from both sides, and then we're going to divide by a negative, and again, let's find my little happy face here. Put that there, because I know I have to divide by a negative, so I'm going to flip it, and I flip my inequality sign, and I get x is greater than 1. Well, what does that look like? Here's our graph. So we have x is less than negative 3, so that's going to be an open circle because we don't want to include the negative 3. So anything less than negative 3 or greater than 1. And again, we don't want to include the 1. We don't have the underline there, so we can't include it. So anything greater than 1. So we could have the number 4 or the number negative 4 would be possible numbers we're looking at here. See if we've got a next example. Oh, we're done. Okay. Tomorrow in class, you'll be working on the quick check together. I'll save some time to discuss compound inequalities. It's important that you understand compound inequalities before we jump into the next lesson of absolute value inequalities, as they are basically creating your own compound inequalities. So again, compound inequalities are joined by the words and or. And depending on if it's and, you want the number that fits both criteria. And if it's joined by or, you can take from either one. Think about this. When I say to my husband, I want something with chocolate and peanut butter, okay? He better bring me a Reese's peanut butter cup, right? Now, if I say, I'm hungry for chocolate or peanut butter, well, he could bring me some chocolate ice cream or a peanut butter sandwich, and both of those would be sufficient, okay? I don't need the overlap with the or. I only need the overlap with the and. So the and fits both parts of the inequality, and the or only needs to fit one. I would like to leave you with this thought. What happens in an and situation when there's no overlap? Second question to think about, what happens in an or situation when the inequalities come together? Ooh, another thought-provoking question for you. Maybe you'll have some answers for me in class tomorrow. Have a great night.